linear systems in chapter 3. So lines, but not just one line, like two lines and how they relate to each other, or how you find the solution between the interaction, the interception. That's not the word I want. What's the word I want? Intersection. That's the word I want. Of two lines. So a system is really just two or more equations. Okay. When I talk about this system, I'm talking about 2 or 3 or 4 equations that have a relationship. Okay. When you solve a system, you're just looking for what makes all of the equations true. So the overlap, right? This is true for this equation, it's true for this equation, and it's true for that equation. That is your solution to your system. So you'll have a couple different scenarios. The first one is probably the most common, and that's when two lines, if you find the equations of two lines, they will intersect. Notice they meet right here, okay? Intersecting lines, we say, are independent. Okay, meaning there is going to be one solution, and that solution is just a point, some x and y value. Okay, that's called an independent system. Those are intersecting lines. Coinciding lines is really just the same, it's a different equation, but if you put them in the same form, both into slope-intercept form, they'd actually be the same equation. Okay, so they'll look like different equations to start, but they're actually the same line. Okay, so coinciding lines are just the same line. We call those dependent. They depend on each other. Dependent. That looked funny to me. With dependent systems, how many solutions do you think you have? It's not 2. And it's not 0. Infinite, right? Because your line keeps going, and this line is exactly the same as the other. So every point on those two lines, which is really one line, is a solution. So you're going to have infinite solutions. Okay, because they are the same line. Okay, so you have independent, one solution. Dependent, infinite solutions. Every point on that line is a solution. And then the last one is parallel lines, and we call these inconsistent. How many solutions do you suppose you have for parallel lines? 0. There are no solutions because they never touch each other, right? We're looking for the intersection of the lines, and these will never touch, so there's no solution. Okay, they are parallel lines. Never gonna touch. Okay, so I'm less concerned about the top word, the independent, dependent, inconsistent. I'm more concerned that you know how many solutions there are and that you could give me those solutions, okay? So just be aware of that. If you're having trouble memorizing one of the words, I'll focus more on the bottom line than the top line. Okay, so today, the first thing we're going to do is we're going to solve by graphing. Do you love to graph? I love to graph. And I did these in 2 different colors, but I don't necessarily love doing this in black on here just because the other lines are in black. So I think what I'm going to do is I'll do red and like a purpley blue color. So this line I'm going to do in this color, and then the red line I'll do in red. Where do you go to graph y equals x minus 1? -1 goes where? Up or down? Down, right? So this is your y-intercept. So make sure you put it on the y-axis. I think the most common mistake I see is people put it on the x-axis. Which one's your y-axis? The vertical, right? So this is our y-axis. So we are going to put a point at -1. And then what's your slope? The slope is 1. So you're going to go up 1 to the right 1, up 1 to the right 1, up 1 to the right 1, and you get this line. Now, you may go as far as you want, up and over, up and over, up and over, up and over, but try to be as accurate as possible on your graph, because the deal is, if you're not drawing nice lines, you're going to have an issue because your lines aren't going to meet where they're supposed to meet. Okay, so make sure you draw nice straight lines and just give a lot of points just so you're more accurate. Okay, so that's the first one. This one, we're going to plot the +3. So 1, 2, 3 would be here. And then we're going down 1 over 1, down 1 over 1, down 1 over 1. So we get this line. Okay, it says solve. What are we solving for? A point. Yeah, we're looking for a point of intersection. So where they met is our answer. So our answer on this one is this point right here, which is the point what?
2, 1.
2, 1. So that is your answer along with your graph. Questions on that? Okay, so that's when they're in slope-intercept form. What is this form? What's the form of those lines?
Standard.
That's standard. And in standard form, what method did we use to solve? You just did this on your test. Do you remember what it was called? What?
Change it to slope-intercept.
Okay, so you could do that, and that will work, but it's a lot more work than you need to do. What's the other way you could do it? Henry? Find the intercepts. Find an x-intercept and a y-intercept and draw a line in. Now, what John said is totally true. If you're having trouble finding the intercept, you could put it into slope-intercept and solve it that way as well. In this one, that's pretty easy. If you wanted to put them into slope-intercept, these are not complex equations. Sometimes it just doesn't lay out as nicely. So we would say for this top one, okay, our intercepts are going to be, our equations, 2x equals 4 and y equals 4. So we divide by 2, and that means x is going to equal 2. So those are your intercepts, okay? And you plot intercepts on the axis we're working with. So if x equals 2, that's an x-intercept right here. Y equals 4, 1, 2, 3, 4. That's right there. So that's going to be our line. Do you have a question? The other one, this one, your two equations are x equals 2 and negative y equals 2. So you just need to divide or multiply by negative 1. So y is negative 2, x is positive 2. So x-intercept of positive 2 and a y-intercept of negative 2 looks like this. So what's your solution? There's one solution. What is it?
2, 0.
2, 0. It's the point, right? We meet right here at 2, 0. Okay, so you're looking for intersection. Where do they meet up? Far so good? Okay, let's look at this one. What kind of line is x equals negative 4? What was that, Sean? It's this way. Yes, it's vertical. X equals negative 4 is a vertical line. Y equals is a horizontal line. See how this just carries over? That's the beauty of algebra. It's just, we've done this. We've just done this. So x equals negative 4, 1, 2, 3, 4, is any point that has an x value of negative 4. So that would be there. Y equals 1 is any point that has a y value of 1. So that one's going to be here at a y value of 1. So what's your solution? Negative 4, positive 1. Okay, name the point. All right, last graphing here. Consider the cover-up method right now. Will you get nice answers? You'll get nice answers for some of them, right? For the bottom one, for the red equation, you'll totally get nice answers. For the black equation, you're going to have a negative 3x equals 8, which is just not a nice answer. So you might want to just rearrange and put that into slope-intercept. You don't have to. You could do the cover-up and hopefully your approximations will fall nicely enough. But I recommend changing that into slope-intercept. So do this for me. Turn this equation into slope-intercept and then graph that. And then the bottom one, if you want to do slope-intercept, you can, or if you want to just do the cover-up method, you can. But I'm going to let you try this one on your own. Okay, so turn the first one into slope-intercept, graph that, and then graph the bottom one whichever way you want. Anyone have a solution for me? It's not what I got. -4, -2. Anybody else get that one? Yeah. Okay, so here it is. If we're going to turn this into slope-intercept, I'm going to add 3x, so it's going to be 2y equals 3x plus 8, right? And then we're going to divide by 2. You divide everything by 2, okay? So this is y equals 3/2 x plus 4. So if I'm going to graph that, that's going to be a +4, 1, 2, 3, 4. Okay, and then it's up 3 over 2. If you want to do another point in the other direction, where would you go from the original point? Down 3 to the left 2, right? We would want to keep going in that same order. So 1, 2, 3 over 2. That would put us there. 1, 2, 3 over 2. 1, 2, 3 over 2. You don't have to do all of those points. It's just going to give you a nice straight line to actually hit the points we're supposed to hit. So that's kind of up to you how accurate you think you can draw it with or without extra points. I would do the cover-up method for this other one. So x equals -8 and 2y equals -8. So divide by 2 here. So y is a -4. Okay, so those are your intercepts if you want to do it that way. Did anyone do it the other way? Because you totally can. If you want to put this into slope-intercept, it would be -x minus 8 and then divide by 2. And you would get y equals -1/2 x minus 4. Okay, so you could plot that equation as well. That one's probably easier to graph nicely. Just because an x-intercept of -8 kind of falls off here. 1, 2, 3, 4, 5, 6, 7. So it would be like here. And then -4, 1, 2, 3, 4 would be here. So you draw that line in. Okay, but if you did it this way, you have a y-intercept of -4, and then it's down 1 over 2, or go the other way, up 1 over 2, up 1 over 2, and so on and so forth. So either way, you should be getting an answer of -4, -2. Any questions on that? All right. So just a little practice, this last set here. It says classify without graphing. We need to know what do you want? D? We need to know what those equations look like in the same form, in slope-intercept form, really, because that's the most basic setup of it, where you will get, are they the same line? Are they parallel lines? Are they going to intersect somewhere? So let's just talk about what that would look like here. Okay, remember, independent means intersecting, independent, intersecting. Dependent, like a dependent is in the same family. If you're thinking tax purposes, my dependents are my children in the same family. And then inconsistent is like, nope, we never see each other. We never touch each other. We are inconsistent. We are separated, parallel. So if you're looking at these two equations, this one is in a beautiful form already, right? Y equals 2x minus 3. The second one, we need to rearrange a little bit. How do I put 6x minus 3y equals 9 into slope-intercept? What are we going to do? What's your first step? Take away the 6x, yep. So take away 6x, take away 6x. So we have negative 3y equals a negative 6x plus 9. And then what do? Now you're going to divide by negative 3. And that's everywhere, okay? Divide everything by negative 3. So y equals negative 6 over negative 3 is a positive 2x. And then 9 over negative 3 is a negative 3. So we end up with this equation and this equation, right? Because we just replaced the second one with this bottom one. What do you notice? They're the same line, right? Y equals 2x minus 3 and y equals 2x minus 3. So is that independent, dependent, or inconsistent? Dependent, same line. Okay, these would be dependent. If you told me same line, I would be okay with that. Okay. All right, and then letter B. The second one is in the form we want it in already, so we'll just leave that one be. The first one, we're going to put into slope-intercept form. So take this equation. I would subtract 8x, so negative 8x plus 20, and then divide everything by negative 4. So this is y equals 2x minus 5. Okay, so we are looking at these two equations. Y equals 2x plus 3, y equals 2x minus 5. First of all, are they the same line? No, they have a different y-intercept, right? Are they parallel lines? Yes. How do you know they're parallel lines? Same slope, right? 2 and 2, but a different y-intercept. So that's what you're looking for. Check the slope, check the y-intercept. If both of them are the same, they're the same line. If just the slope is the same, then it's going to be parallel lines. If the slope is different, but the y-intercept is the same, what's that going to be? That's going to be the independent. They will intersect if they have the same slope, or sorry, same y-intercept, but a different slope. Okay? So what is this one called? This is inconsistent. Okay, they are parallel lines. Questions on that?